Hello, everybody. Welcome to KETIV Virtual Academy. My name is Tom Fitzgerald. This week on KVA, we're going to be talking about external data sources for any of your Inventor automation that you might be doing. Being able to access other information and kind of leverage it within your automation solutions. So, my name is Tom Fitzgerald. I am the practice lead of the design automation team here at KETIV. I regularly host these KVAs, but not all the time. Sometimes our other practice leads might host them, or other individuals that have some very relevant and important information that they might want to share with you. So this week, it's going to be me. So thank you all for joining. Let's get into it. All right. A little bit about or the agenda for what we're going to be discussing today, a little bit of introduction about myself, of course. And then we're going to get into the different types of external data sources, be it Excel, XML, or even SQL Server. And then at the very end, I'll give you guys some time to ask some questions, and hopefully I'll be able to give you some answers. So a little bit about myself. Like I said, Tom Fitzgerald. I am the design automation practice lead. I'm also a solution architect. Worked at Autodesk for 10 years as a solution architect, implementation consultant, technical consultant, business consultant, all sorts of different kind of consultant roles up at Autodesk, depending on the nature in which I was needed in terms of those particular projects. Been in a 3D design environment, if you will, landscape, working with 3D design tools for 25 years, quarter of a century. That's crazy. Been working in the manufacturing industry for 30 plus years, though. Various types of positions. Most of my background has to do with heavy machinery, material handling, conveying systems, primarily things like that. I'm also a U.S. Army veteran. Spent 7 years in the United States Army back in the day. And in my free time, I'm a World War II historian. So I like to do a lot of research and understand a little bit more around that very critical time in world history. All right. So before we get going, I have a poll. I'd like to ask everybody some questions here. Let's see if I can pull this up. So how familiar are you with using external data sources? Any of you that are using external data sources right now? Maybe this is your first time ever hearing about it. Maybe you use them every single day and you're a professional like myself. So we're getting some responses rolling in here. Quite a few of you are saying not really at all or very, very little. So these are the numbers in which we have so far. Most of you, the vast majority, 2/3 at least, very little in terms of external data sources. So good, I'm glad you're participating in this KVA. And hopefully you'll get a little bit more information around what external data sources can do for you. Here we go. Here's the actual results right here. So now you can see them. Sorry, my first time ever conducting a poll on Zoom. So I appreciate your patience. All right. So now that we understand that most of you should find some relevant interest in external data sources. So what I like to do is whenever I have this conversation, I'd like to throw this graphic up to kind of let everybody understand what are the different elements around building out some sort of automation. In this case, it's more like a product configurator is the example here, but really it does demonstrate how everything kind of connects in most instances. Obviously, you're going to have a few things. So in many cases, data is used to support automation within the models themselves. In other cases, that information, that variable information, might exist in other files or even other systems. So in order to maintain that digital pipeline of information, you input it over here, and then you do something over here with it. In order to kind of is that manual interaction with working with data, external data sources can provide some assistance in that regard. Can be leveraged to input, edit, and then output variable information needed for model and even drawing configuration. So if you're looking at this graphic here, you'll see right here where my cursor is kind of swirling is really where within this workflow external data sources kind of live, right? So we have a UI where individuals input information. We have some business logic. It could be iLogic, it could be Visual Studio, it could be .NET information that is accessing methods from the Inventor API. And then that logic typically, and sometimes the UI, may interface with external data sources in order to collect some information to make a decision sometimes, or just to pass that information down through the automation to reflect within the models. As an example, perhaps you have costing information that is associated to different models or different processes in order to create or fabricate different information. Well, if that costing information exists in some sort of external data source, wouldn't it be advantageous to be able to, once you have a configuration, to go and grab that information out of that external data source and then display it somehow, maybe in a parts list, maybe output it as some other file that could then be leveraged, like say a shop traveler or something that might be more valuable to the end user. So there's a number of different things to kind of think about or consider when we're looking at this particular graphic on the screen here. But external data sources, it's out there. We typically use a UI or the business logic and go and collect that information and then pass it down to whatever we might need in terms of a model configuration or any drawing automation that we might have in place. So that's really how external data sources kind of play into that whole scheme of building out automation. So what are external data sources? Typically, they're other files or another system in which you might interface with. Typically, the data is manually entered in designs. Like imagine you have a product configurator, if you have some iLogic stuff, you can use an iLogic form to input information, parameter information, property information. Parameter information could drive your size and shape of the different models that you're using. Maybe the end user doesn't know that information right up front, or maybe some information, but an external data source might have more complementary information that's associated to it. So as opposed to relying upon the user to know everything, maybe they only need to know a little bit. And then you can go out to systems or other files and collect some information that's relevant to that input information that the user provided. So think of it that way as another way of storing tribal knowledge as well. Other Inventor files could be data sources. If you're familiar with using the iLogic rule editor, when you have an assembly, you can access lower level components right from the browser tree, and you can access parameter information and property information. So think of it as from an upper level assembly perspective, reaching down into some of those lower level components and grabbing property information or parameter information, and then bringing it up to the upper level assembly. That, in essence, is an external data source that you're going down to a different file and you're accessing information and then consuming it. And then the most common external data source that we're really familiar with is Microsoft Excel. Inventor has some native functionality around using Excel files. Think of the parameter dialog box where you can import and export parameter information. You can also link to an Excel spreadsheet that might have parameter information. We've seen this many times throughout the evolution of Inventor. Being able to use an Excel spreadsheet, plug in some values, run it, and then iLogic or some other mechanism will then update a model based upon that input information. So in some instances, some companies are using an Excel spreadsheet like a UI, if you will. So why would we want to use Excel? Like I said, there's native behavior and functionality inside of Inventor. It's very familiar. A lot of people understand Excel, and it's quite honestly, it's really easy to use. You have cells, you have rows, you have columns, you have different sheets. And if you can understand that in its basic form, then you can organize information in such a way where you can make calls to an Excel spreadsheet and pull information, very specific information at very specific times. So it's very powerful in that regard. All right, so some demonstrations. So let me go and I'm going to pull up Inventor here, and we're going to talk a little bit about Microsoft Excel. So let's see here. Go to Inventor. So I have a couple examples that I want to show you about leveraging Excel in a capacity of what I'd like to call like standardization utilities. Okay, I had a customer come to me and ask, hey, we have a real tough time ensuring that our property information, both standard properties and custom properties that are linked inside of Vault, we have a real rough time ensuring that they're consistent and they're standardized. So what we'd like to do is to be able to give our users an opportunity to use a user interface and then be able to make different selections. But because of the dependencies between the different properties, we want to be able to have those lists dynamically update as users make selections. Now, those of you that might be very familiar with using might understand, hey, this is rather difficult to do if you're using iLogic, but if you're using Visual Studio, it's very simple to do. But I'll show you some things that we can do here. So I do believe, am I sharing the screen still? It says I'm sharing my screen, but I'm not seeing the outline there.
Yes, we can see your screen.
Okay, thank you, Christine. Thank you. Okay, so what I want to show you here is this example that I built. So here it is, all built inside of iLogic. It leverages an iLogic form. It has iLogic external rules that we're leveraging here that do certain things, and I can expose those here. So there's a number of rules that are firing here. I'll get into what these really do in just a moment here. But essentially, how this works, if I pop open this form, you're going to see, well, a lot of this is blanked out. And this is because this is just a standard form or a standard file. It's just a blank template. It's not been saved before. I just fired it up. And so there's no parameters, no properties. It's not built out. There's no framework involved. It's just a regular file. Okay. So what I've done here is I've created an opportunity call or a rule called validity check that goes and does some very specific things. Like it goes out and it runs something, and basically it just prepares the file for the automation. Okay. So what it does is it goes and builds out some parameters, some properties, it collects some information, and it pre-populates this form. So now I have some drop-down lists here. So as you can see, if I select windows or if I select doors, the subsequent fields here all update based upon this first selection. So if I make a selection here, and then I make a selection here, these subsequent lists will then update, and so on and so forth. So it's a way for me to dynamically attach information. Whatever I select from this row affects this one, so on and so forth, all the way down. And then I go in and I fill in some other information, not caps lock though. And then we'll say that, and I'm going to say populate properties and close the form. Okay. So essentially all that was doing was allowing the user to make some selections from a form, and then it goes back and then it goes and populates these custom properties that didn't already exist. So part of the preparation of the file was to ensure, hey, do these properties exist? If not, let's go ahead and create them. So that's part of the logic. What we really is, well, how did all of this work? So where does the form information come from? How do I maintain the dependencies between the different fields here? That really comes down to the Excel spreadsheet. And let me pop this open real quick so I can kind of show you a little bit about that particular organization. Right. So I have this Excel spreadsheet. And what I've done is I've formatted the Excel spreadsheet in such a way where there's a schema that's involved. Okay. So I have this start page. In the start page, I have the different parameter names, the different parameter types, and the different parameter values. So this start page is where I go to understand how do I prepare a file to be able to be used with the automation in which I created. Okay. So whatever is listed here in terms of parameter names, types, and values, this is what the automation uses to validate if these particular parameters exist within the file that I'm using. If they don't, it goes ahead and creates it. Same thing with properties. Do these properties exist? Are they custom? Is there a parameter associated to them? Is it required to be filled out? So I'm supporting that functionality by using an Excel spreadsheet schema. So I'm basically, with the logic, I go in here, read this information, go and create my parameters. Go and read this information, go and create my properties. And then, of course, I need to have a starting point for dependencies of everything that's supposed to be tied together. So I have that outlined here in terms of product lines. And does it have a schema, yes or no? If it has a schema, then I want specific logic to run to collect information from these other sheets. If there isn't a schema involved, well, then I don't need to worry about that. So that's a way for me to make some sort of conditional decision around what I want the logic to do or what information I want the logic to collect. Okay, so it's really about going ahead and understanding what information do we need. How do we tie it together in order to create these dependencies? And it really all comes down to what is the best way to format your Excel spreadsheet in order to accomplish that. Okay. From a logic perspective, let's go and take a look at what am I doing to make this happen? So I have this rule and it's called collect data. And what I like to do, and I have a very specific methodology that I like to leverage whenever I develop these types of projects. And it really comes down to this. You want to go and you want to access your information as minimal amount of times, as few amount of times as you possibly can. And what I mean by that is, if I have a rule that goes out and opens up an Excel spreadsheet and I want to get some information and I want to do something with that, what I want to do is I want to go to that Excel spreadsheet as few times as possible. If I have 20 different functions that I need information from Excel to do something, I don't want to go to Excel 20 different times. Open Excel, get something, close Excel, and then process that information. What you'd want to do is you want to go to Excel one time if you can. Collect everything that you need, store it in memory, organize it, format it, whatever you need to do with that data, be it in different arrays or different lists or things along, multi-dimensional arrays or different lists. You could use that as well. So go and collect as much information as you can one time, store it in logical containers, and then go and access that information in memory when you need it. Because that is by far faster than if you would just go to Excel, get a little bit of information, close Excel, and then have to go back and reopen Excel. So with that being said, you'll see within my rule here that a lot of what I do is I try to go and collect my information first and then organize it in a way that I can go and repeatedly access it in memory as much as I need to. Okay. So a lot of what I'm doing here is you're going to see I'm going to create a whole bunch of different array lists. I need placeholders. I need some place for this information to exist. If I go to Excel and I want to read all the information in a particular row or a particular column, well, then I need to store that somewhere. So I'd like to use lists to do those types of things. And sometimes you can create lists of lists. So you sometimes might see me do stuff like that within my rules as well. Once I get define all my lists, then what I want to do, loop through Excel on the start sheet so I can get all the different parameter names. So I'm collecting the parameter names, I'm collecting the parameter types, and I'm collecting the parameter values. I'm putting all those into different lists. And then after that, I'm just going to iterate through all those. So I'm just going to iterate through that and then go ahead and create those parameters and those properties. And what I've done in this particular instance is I've used shared variables a lot. And I think I've talked about shared variables before in one of my KVAs, but just as a refresher, a shared variable is an in-memory placeholder or repository where you can store information. So I see a lot with particularly new users that are using iLogic is, okay, I'm going to process some information in a rule. And then I need the output of whatever I processed. I need that in a different rule. So what do we typically do? Well, we create a parameter, right? So we'll process some information. We'll put that value in a parameter in the model. And then in a different rule, we'll go and read that parameter and then process it again. So you're using parameters and sometimes even properties as placeholders to store information. We don't necessarily need to do that, particularly if you have very complex automation, because you can sometimes turn out to have 200, 300, 400, if not more, parameters. And most of them are just storing information. Maybe they're being used to associate to geometry or something else, but a lot of times they're not. They're just as a placeholder to store that information. Well, shared variables do the same thing. However, shared variables is object-based. So if you want to put text into a shared variable, you can. If you want to put a numerical value, you can. If you want to put in an object, like say an occurrence definition, you could do that as well, or a document definition. So you can leverage a lot of the object definitions from the Inventor API inside of a shared variable. It doesn't necessarily have to be string or numerical or even a Boolean. It can be all sorts of different objects that you want to use inside of your shared variables. So it makes it real easy to then process something or do something within one rule, put it into a shared variable. It's now stored in Inventor memory, and then you can access that shared variable from a different rule. You don't have to necessarily use your parameters to do that, okay? So I use a lot of shared variables in order to store information that I might need in subsequent rules, and then that information gets processed, okay? So the first thing I'm doing is I'm looping through the Excel spreadsheet to collect the information that I need, and then I'm putting it into shared variables. Like I said before, go to Excel once, collect all your information, store it, and then you can consume it later on in other rules. You don't have to keep going back and forth to Excel. And then now that I have all that information, and then what I'm doing is I'm just going through the process of creating all the different product names, product types, and product configurations. So how does that align with what's going on here within the form here? So I have my product lines, I have my product styles, I have my product names, and my product types. These exist as parameters, but the information, how do I populate these multi-value lists? That information solely comes from the Excel spreadsheet. So that means if I ever need to update these lists inside of these files, I go to the Excel spreadsheet, I update it here, then I go back, I run the logic, and then these lists automatically update. They reflect not only inside of the UI, but in the parameters as well, because the UI in this case is leveraging the parameters, okay? So what else? Once I collect that information, then what I want to do is I want to create it and I want to put it into the different lists. So this is now taking the, I take that back. That's the wrong one. I'll get there. I want to create the different parameters, and I want to create the different properties. So I have a number of different rules that once I've collected that information, I'm just going to leverage the different shared variables in order to create the different lists. So in this case, I have this shared variable that I've created in a previous rule. I'm coming back, I'm evaluating that shared variable, just looping through it to see if this property exists. If it does, great. If it doesn't, then I'm going to go ahead and create it and then give it a default value that I'm then going to provide an accurate value to later on, once the user makes that particular selection. So that's what I'm doing in terms of, I have an Excel spreadsheet here. Let me pop that open once again. I have it formatted based upon the information and how I want to consume that information based upon dependencies within the actual automation itself. Okay. So that's one way to use an Excel spreadsheet. Let's just go back to this collect data rule real quick. And I just want to show you a couple of methods that I've done here. So first off, I'm defining my path and my file name by using a shared variable. I'm collecting that from a different rule, and I'll show you that here in a moment. In this case, I'm also using the Inventor progress bar. And if you haven't done this before, the Inventor progress bar is an API call that is really useful. Or if you experience the fact that, say, for instance, you have to go to an Excel spreadsheet and maybe there is just a literal ton of information you need to collect. Well, there's no way to inform the user that something is processing in the background, except for the progress bar. The progress bar is a great way to let the user know, hey, something is occurring here, something's happening, so just be patient. And then now that it's complete, then the automation will then pick up again. So in this case, I'm using my progress bar here, and I'm informing the user that this may take some time to go and access Excel and collect all this information. If your Excel spreadsheet is local, maybe that's going to process a little bit faster than, say, if it was out on the network, maybe not even remotely close from a geographical perspective to where you may be able to access it, or whatever the case might be. So there may be a time delay in terms of accessing the Excel spreadsheet, collecting all the information, and then bringing it back and then closing Excel. So using the Inventor progress bar is a great way to satisfy your user to let them know that something is actually happening. And then from there, I like to use this method right here, this do method. And I found this to be extremely helpful when I don't know how many rows or how many columns I need to iterate through in order to collect all the information in which I need. So I do what is called a do loop, which means I'm going to do this as many times until this line actually hits. And what this line is saying is, I'm going to go and I'm going to say, hey, cell value, if it's empty or nothing, or rather if it's nothing, or if the cell value is empty. So once it hits a cell value that is either nothing or empty, that's when this loop is going to conclude. So if there's 20 rows or 2,000 rows, once it hits an empty row cell, or rather once it hits an empty cell, that's when the loop is going to stop. So understanding some of the limitations or some of the methods you're going to use in order to collect information will also dictate how you format your Excel spreadsheet, right? So in that case, I'm going to iterate through all these rows until it hits 12 here. Now that's how it knows when to stop and then continue with the rest of the automation. So once it hits that empty cell, it's going to stop doing this, and then it's going to go on and do this. So you'll see I have a number of do loops here where I'm collecting very specific but different information. In some cases, I might be going to one type of column, or I might be going to a different type of column to grab that information. So a lot of different methods of iterating through rows or columns, or directly accessing very specific cells on sheets in order to collect that information. And all of that is readily available inside of iLogic, as well as what you can do using the Inventor API to make those calls to Excel, to the Excel object, if you want to. Okay, so in this case, in the collect data rule here, I'm using an iLogic method here to go to Excel, open up Excel using that file path and that file name, and then access the start sheet. So that's where everything is beginning. This is using iLogic to do that. Another way you can do that, let's see here. I have Visual Studio open here. I'm going to close this solution, and I'm going to show you one other solution where I'm using Excel to do something very much the same. And I think it's in this one right here. Yes. So in this example, I'm not using iLogic to open Excel. I'm creating this object called Excel.application. And now this Excel app object is my Excel application. And then from there, I can use that to then open up a workbook, which is in a very specific place, open up different worksheets, go to different cells, different columns, different rows. So it's a different method if you're using iLogic versus if you're going to be using Visual Studio. And quite honestly, what I've experienced is by using this object-based access to Excel gives you far greater functionality when you're trying to access information than if you were trying to do it using the snippets inside of iLogic here. So if we go to our Excel data links here, you'll see find row, find column, find cell, get a multi-value list from Excel, open an Excel spreadsheet, save one, close one, change the sort. So you have some default snippets here, which by are no means everything you can do, but it's a good portion of what you can do. Depending on the type of solution that you may be creating, you might want to use the Excel snippets here inside of iLogic. In other instances, you might want to use the Excel object itself, okay? So going back to our PowerPoint here, let's talk about Excel in terms of there are iLogic snippets available. And if you're using iLogic code, I would recommend using the iLogic snippets. They work perfectly fine. You can use object-based declarations. They're very useful. I showed if you're using Visual Studio and you need to access Excel and collect information, obviously you're not going to use the iLogic snippets. You want to use those object-based declarations instead. You can use a combination of Visual Studio code and iLogic snippets, or rather object-based declarations and the iLogic Excel snippets inside of iLogic rules. But for obvious reasons, you want to try to standardize on a method. Sometimes you get mixed results if you're bouncing back and forth and using iLogic snippets versus using some of those object-based declarations. So you want to be very cautious in terms of which path you follow around accessing Excel spreadsheets. I did find that in Inventor 2022, if you're not using Inventor 2022, it handles background applications a lot better than some of the previous Inventor versions. And what I mean by that is, remember what I was saying, you want to access Excel, collect information, and then you're going to close Excel. In previous to 2022, I have found that if you go and access an Excel spreadsheet and you don't explicitly close the Excel spreadsheet, it stays open in memory in the background. So if you go and access Excel, collect some information, and then close Inventor or close that rule, and then another rule goes and fires and accesses that exact same Excel spreadsheet, it's going to open up another instance in memory of that Excel spreadsheet. And if you're not monitoring and if you're not really conscientious as to what you're doing around closing those within your code, you could turn around and have many, many, many instances of Excel open in memory in the background, and it could impact the performance of your particular computer, depending on your resources. So if you're using Inventor 2022, I found that it's much, much faster. It goes and cleans up and handles those background applications far better than the previous version. So take a look at that. If you're using Excel and you're seeing that that's troublesome for you in terms of those background applications, take a look at Inventor 2022 and do some benchmarking. You'll see it's considerably faster. All right. Remember what I said, go access it as few times as you can, collect as much information as you can. When you do access it, process that information, then output your information from there if you can. Okay. So those are some good practices. XML. So working with XML, I had the opportunity to work with XML just a couple of times, and to be perfectly honest, the first time that I had to work with XML was because I was working on Inventor previous to an Inventor version previous to Inventor 2021. And remember what I was saying is going and accessing Excel, collecting that information, and then closing Excel was taking a fair amount of time, an unacceptable amount of time, to be perfectly honest. The customer was experiencing 2 to 5 minutes of wait time from the time they initiated the call to Excel to the time that we did everything we need to do with Excel and then come back. And some of it had to do with Inventor itself. Some of it had to do with the version of Excel they were using. So there was a couple of different variables that were contributing to the performance degradation of accessing Excel. Well, what I had found was maybe you don't have to access Excel all the time. And I found that accessing XML was far, far faster, up to the order of 100 times faster than accessing Excel. Well, when you start thinking about, well, if I can access XML 100 times faster than I can access Excel, why wouldn't I just want to use XML? So in this example that I have here with same customer, you'll see that I have this create XML rule here. And what this does is, in an effort for myself to provide the customer a better solution, a more robust, more performing type of solution, what I did is I came up with a method, actually, let me back this up, that validates if the information inside the Excel spreadsheet matches the information inside of the XML, okay? So what I'm doing is I do this validity check first, where I go and I look at the XML and I go and look at the Excel. And what I'm doing is, first, XML doesn't exist. Then I'm going to there's no XML, and I need to go and create that XML. If they say yes, then I'm going to run the collect data rule, which will then go to Excel, collect all the information, put it in the lists, and then it takes that information from the list and generates an XML. Okay. So that's if no XML exists. So basically, first time run. So the first time it runs, it goes and collects everything, creates the XML. The next time it runs, what we're going to do is we're going to check the modified date on both the XML and the Excel. If the XML and the Excel are aligned in terms of the date, meaning if the XML was created after the Excel was modified, then we can, with a certain degree of accuracy, understand that the XML is accurate. So if that's the case, then we're just going to read the information from the Excel spread or the XML. And that's what this is doing here. So if the XML is within, date, if it's up to date, then let's just use the XML because it's 100 times faster. If the XML is out of date, or if the XML doesn't exist, then we're going to read the Excel, collect the data, and then create the XML. Okay, so that's what's occurring there with the validity check rule. And then once I have the information in the different lists, this is what I'm doing in terms of creating an XML. So inside of iLogic, very, very simple. We only need to add the system.xml reference. We need to import the system.xml. And from there, then we can access the parameters of the XML object, meaning we can define an XML document. We can define the different XML nodes. We can create the different elements underneath those nodes and give them names and understand what needs to be associated within those XMLs themselves. Unfortunately, I do not have an XML reader on my computer, so I'm just going to use Notepad here. So this is the XML that gets generated from the Excel spreadsheet. All I'm doing is, what are my different lists? So kind of aligning with what's in the user interface or the different lists that I need to create. What are the list names and what are the list values? And that's all I'm doing. So whatever I collect from the Excel spreadsheet, I'm putting into shared variable lists. And then I'm iterating through each one of those lists to then output that information, the nodes, the elements, and the values inside of the XML spreadsheet. That way, whenever these rules run, it's always just going to grab the XML information as opposed to the Excel. Now, why, aside from performance, why is this even valuable? Why is this important? Well, you also have to take into consideration security, okay? If your Excel spreadsheet is your source information, do you want that source information out there amongst numerous computers? Not really. You want to maintain a single source of truth, right? So logically, you would probably take that Excel spreadsheet and put it in Vault, or put it in a centralized location where you can secure it so nobody is making changes to that information arbitrarily, right? You want to have certain control over that, okay? So you put the Excel spreadsheet in a centralized location, and as the logic goes and runs the validity check, it's going to go to the Excel location, but it's going to look locally for that XML. And if that XML doesn't exist locally, or if it's out of date locally, then it's going to collect that information and create that XML locally. So that means the only time you're accessing that XML or that Excel spreadsheet is to ensure that it's up to date. So 99% of the time, 99.9% of the time, it's always going to pull information from that local XML, preserving the information in the Excel spreadsheet for security purposes. So now you have document control in place. You have a level of accuracy of the data that's in the Excel spreadsheet. Nobody can touch it except authorized users. And the XML information is just a reflection of what's in the Excel spreadsheet. So now you've satisfied a performance issue or a performance requirement, as well as a security requirement. So really cool in terms of what you can do with XML in that regard. And mind you, this is literally just scratching the surface of what you can do. You can see this rule is relatively short, and that's because I've prepared the information in the specific lists first, and then I'm using that list information in order to generate my XML. And then, of course, I'm just doing the reverse process in terms of reading it. Now that I have the XML out there, like I said, I have all the node information, I have the list information, I have the element information, and I can just reverse the process to collect that information and put it inside of the lists as necessary. Back to the PowerPoint here. So things to know about XML, extensible markup language, that's what it stands for if you didn't know that. It's very fast to read and write data if you need to. The structured format of XML allows for a very, very simplified methodology of acquiring and accessing that information, okay? And it's a great method to save and store configuration states. I didn't even talk about that. At the moment that you have a product configurator, you have some iLogic rules out there, you have a form, you're inputting some information, and then you're going ahead and it's churning through that logic and it's creating a particular configuration. Well, you could write a rule that collects all that variable information that's very specific to that configuration, and then format it, and output an XML that basically captures the state of that configuration. Okay, and you can just put it out there somewhere. And then you can create all sorts of different other configurations and output XML, output XML. If you had a method that could then read that XML, input that parameter and property information back into the UI and churn through it, you'd be able to recreate that configuration on the fly relatively quickly. So XML is a great way if you have a product configurator or drawing automation in place and you want to be able to capture a state or be able to recreate a particular configuration state. XML is a great way of capturing that information as well. To our last topic here, Microsoft SQL Server. Now, a lot of companies have some sort of database application in play, right? You either have SQL, you have Oracle, you might have Access, Microsoft Access. There's even some free cloud-based, like MySQL, I think, is a cloud-based database application. I haven't worked with like Oracle or MySQL or even Access. I've only worked with SQL Server in terms of developing database tables. And most of that is simply because of Vault. I mean, if you're using Inventor, most companies that are using Inventor are using Vault as well. Vault leverages SQL Server. You can go right into the SQL Server database, create your own tables in there, and then, you know, have them segregated or separated from the Vault tables and have your own tables in there that you want to use for other purposes. You're already paying for the SQL Server instance in it because you're using Vault. So you might as well just leverage those databases and create your own tables in order to support your automation as well. Okay, so that's what I've done with a couple of my my projects. Is customer already has SQL, let's just leverage SQL to provide what we need in terms of database functionality. Okay, let's see here. So in the case of SQL, some of the things that you need to be extremely aware of if you're going to be using SQL is there's no real magic involved with SQL in terms of how you make your different calls to SQL. So let's see here. What am I wanting? I wanted to look at this one right here. Okay. So if you want to access SQL, there's some very specific information that you need to be aware of. And the first thing is, just like any other time that you need to access a SQL Server database, you need to authenticate. You need to have credentials. You need to understand, well, what data source are you accessing? What database are you accessing? What specific catalog are you accessing? So this is my SQL Server instance. This is my SQL Server database. And then, of course, what is my security type? And there's a couple different security types here. You can use your integrated security type. If you have an authentication username password combination that you want to provide, you can put here inside of the code. I've also seen another method where for security purposes, you don't want to divulge that information. You don't want it inside of, you don't want it hard coded in your solution, where you may be able to use a variable that then goes to some other system, accesses that information, pulls it in. So that way you have some level of security in terms of how you access that authentication information. Is the first thing that you need to do is you need to get access to your SQL Server instance. And that's done through this connection string right here. Once you have your connection string, then you want to make your connection, which is you're creating a new SQL connection using that connection string. Now that you're connected to SQL and you're actually inside of the database instance itself, now you need to make your SQL queries. And this is what I was talking about. There's no magic here. If I wanted to go into my SQL Server database dashboard, where you can go in and you can start creating tables, editing tables, doing different queries within your tables, you have to do things in a very specific order of how you want to access that information. Like What database do you need to select information from? What is your criteria? What are you looking for? What are you trying to evaluate? Or different information that is relative to key identifiers and different rows and columns. So you have to syntax your SQL queries exactly the same way as you would have to do it inside of your SQL Server data management console, okay? So a lot of those same query calls are going to be exactly the same inside of your logic here as what you would do inside of the console itself. So you have to syntax it, your selects, your froms, your wheres, give it your evaluation information. And then from there, now, once you start building out your selection statements, your selection strings, then you can compile them and then actually make your SQL commands, okay? So I'm going to make all my selection statements, and then I'm going to come in here, I'm going to create a new command object, and then I'm going to run that command, okay? So there's a lot of preparatory work that you have to do here in terms of understanding your database and a database table schema. How is it organized? How is it structured? Where are the dependencies? Are there any key identifiers involved? Once you have that figured out, then you're going to know what kind of calls you need to make to SQL Server in order to get those responses. And then that's what I'm doing down here is once I make those SQL commands and I apply those SQL query strings, it's going to give me some sort of return. And that's what the SQL data reader does. So once I've made the SQL query, then I'm expecting some sort of return from SQL. Where is that going to go? It has to go into these SQL data reader variables. So I'm creating reader 2 in this case as a data reader, and it's going to get the response from this SQL command, this command. So once I get that response, now it's some sort of information, and then I can then process it. Do I need to make it a string value? Does it need to be a numerical value? Do I need to have a particular level of precision in terms of a decimal place? Do I need to concatenate that information? Whatever the case might be, it's the same process. Make a connection to SQL, build out your SQL query strings, provide those strings, have some place for that information to get returned to, and then now you have that information, then you can then process it, okay? And then once it's done processing, then you go on to the next thing, okay? So it's pretty structured. It's not very, if you're not very familiar with SQL, it's very difficult to understand the exact method you need to follow in order to make sure it works right. However, I do have this example information. I'll be more than happy to provide this to anybody who wants to use it. You can then, copy paste, mess around with a little, see if it works for you. If you have SQL in place, go right ahead. I highly encourage you to do so. All right, so back to our PowerPoint. So some things to be concerned about in terms of SQL Server. Well, beware of authentication. Understand what your authentication structure is inside of SQL Server. If it's wide open, obviously it's going to be super easy in order to access your instance. But if you have, like, say, Windows authentication set up, or if you have some other authentication service that you're running, you want to make sure you're aware of that and cognizant of its requirements, okay? It's also good to have a basic understanding of what SQL queries are and how to best use them. Obviously, like with anything else, the shorter, the more simple, the better, but also make sure that it's adequate, that you're getting the information in which you need. SQL can support very, very, very large amounts of data, terabytes upon terabytes upon terabytes of data. So understanding that you have this system out there that has a bunch of information readily available to you, now it's just understanding, well, what information do I need to access? In a lot of instances, depending on your environment, you should be able to make direct access to SQL in order to consume data. In other instances, you may not have the permissions, or your security model inside of your company may be too tight for you to be able to do that. In which case, you can come up with other database strategies where maybe you have a system that goes and collects very specific, focused information from these systems and takes that information and puts it into an intermediate database that you do have access to, that you can directly get information from. So imagine you had an ERP system that had Oracle as a background or as a foundation for your database. You may be able to develop some automation or routine that goes and collects that information from Oracle, very specific to the information you need for design, and puts it in this intermediate SQL database that your iLogic automation can directly access and then use for your design purposes. So you don't have to go straight to your ERP system. You can go to this intermediate database that is synchronized with your ERP system on a regular basis to ensure it's up to date. So there's other strategies that you can leverage in order to get that information out of highly secure databases as necessary. And that's really what I wanted to get to. Okay. In review, we're coming to the end of the KVA, and I did not leave a whole lot of opportunities for Q&A here. But just to kind of recap, there's lots of different options available to store and edit and access information. Hybrid environments, although they may work, you always want to try to keep it simple. Simple is always better. And what I mean by hybrid is I'm getting information over here from Excel. I'm getting information over here from SQL. I'm getting other information from Access. You kind of want to standardize if you can, but obviously, you can make hybrid environments work. Plan. I say it all the time. Whenever you're doing automation projects like this, it's really good to whiteboard it out, plan it out, figure out some sort of story behind it and all the different elements that are going to be involved to ensure that you're accommodating all the different criteria and all the different requirements. Far too often do I engage with customers where they say, well, I want to put in automation. So they have an immediate problem they're trying to solve. And then as they keep going through this journey, they're finding other problems, and they just keep kind of slapping it all together and cobbling it together to make some sort of solution. Sometimes that works, but a lot of times things can get very much out of hand. So if you plan ahead, make sure you reel it back, take a step back, take a bigger look at the picture, and then start planning out and understanding where these dependencies might lie. When it comes to SQL and actually Microsoft Office, watch out for licensing and different versions. If you use an Office 365 versus an older version of Office, some of the methods might need to be tinkered with a little bit to make sure that they function appropriately. And there's a ton of information out there on the internet. Google is always my friend, but make sure you do your homework. Don't rely on the first response that you get because it may not work for you. Dig around, do some researching, kind of get a compilation of different solutions before you determine on one. Okay. I think upcoming events, we have a digital manufacturing series coming up here on March 9th, another KVA March 10th, 5 ways that automation or sales automation can help you. So just want you to be aware of some upcoming events. And now lastly, I'll open up for Q&A. So I have one question in the Q&A. Is there an advantage to using do versus while loops in iLogic? It all really depends. Like I said before, I do the do loops because maybe I don't know how many rows there are. You could do a while, accomplish the same thing. It really kind of depends on what is the outcome that you're looking for. And of course, is there a level of predictability versus non-predictability involved in the type of loop that you're doing? So most of the time it comes down to personal preference rather than level of functionality. All right, that's the one Q&A. I see some things here in the chat that I'd like to address before we call it a day. I got the poll window. Thanks for clarifying. Excel 2016 performing timing issues. Was just testing Excel code snippets and kept failing in Inventor 2019. Yes, please try it in 2022. I'm sure you're going to be happier with the results there, Jerry. I found using iLogic's Go Excel methods less reliable. Exactly. And this is what I'm trying to say is that you may have mixed results depending on your version of Inventor, your version of Microsoft Office, and sometimes just your code structure. Your code structure sometimes can be a limiting factor in terms of your performance with working with Excel. Creating an object for the Excel application is definitely more reliable and powerful. I couldn't agree more. Quite honestly, I try to use that as much as possible, but don't disregard the iLogic snippets. Particularly if you're just starting off with automation, you're getting your feet wet, you're trying to understand things, go ahead and use them. You may not have the best performance right away, but at least you'll get more familiar with automation solutions, requirements, criteria, and then, like I said, you'll build your knowledge base from there. All right. Well, everybody, thank you very much. I appreciate your time. Once again, we've consumed an exact hour for this KVA. Not too bad. Everybody, if you don't know me by now, my name is Tom Fitzgerald. Anybody can reach me at thomas.fitzgerald@ketiv.com or just get for me by name, and I'll be more than happy to give you some information and supply any examples that you might need if you're going through your own design automation journey. Thank you very much for your time, and we'll see you on the next one.